Yeah. Okay, this next one. Stop. The line of reflection is the line that you flip over, okay? And it says if a point A is on the line of reflection, then the image of A is itself, right? That's what Forrest told us up here. So if A is on the line, A prime is the same point. It is itself. If B is not on the line, so that's like our B up here, then it's the perpendicular bisector. M is the line of reflection is the perpendicular bisector of that line, okay? So perpendicular and same distance away. And then the last thing, you know what, we're not even going to fill this in. We're going to say reflections are a rigid, just write rigid motion. Remember we said it preserves distance and it preserves angle measure. That means it's a rigid motion, right? Same size.
Are we doing 3?
This 3?
Yeah.
I mean, there's nothing to write, but it's true. That is true of it. We're not going to focus a whole lot on that idea, but a reflection will always be a rigid motion. Okay. It will keep the same size as it was. So here's what you're going to be doing with reflections. It says you have this point F, okay, at the point 2, 6. Where do you move for the point 2, 6?
2 to the right.
2 to the right, 6 up. Okay, so go 2 to the right, 1, 2, 3, 4, 5, 6 up. So you should have a point right there.
How much is that long?
Okay.
Oh, it's like 1 off.
Okay, now look at this. The notation for a reflection is a capital R, right? Remember we said for the translation, the rule or the notation, it's always a capital R and then whatever line that you're going to reflect over, okay? So this is a rule right here. The way you would say this is a reflection over the line, positive 2, 6. Oh, what would it be? Well, you have to look at what we're reflecting over, though. I know why you say that. You're saying the y-axis, right? But this is a little different. So this is a reflection over the line y equals 3 of point F. Okay, that's what this means. So when you see that, think capital R reflection. And then what did I reflect over? Okay, now, if you checked out, check back in. This is probably the trickiest part of the whole thing. The line y equals 3. I need you to think about, where does y always equal 3? Give me a point that has a y value of 3.
Y3.
A point, like a coordinate. What? Where your y value is 3. Pick a number. 2, 3, right? Pick another number. 1, 3. 0, 3, right? Where your y value is always 3 is those points. So think about where those points are. 2, 3 is here. 1, 3 is here. 0, 3 is here. 3, 3, 4, 3, 5, 3, 6, 3, right? All of those points have a y value of 3. Do you see where the line y equals 3 should be then? It's a horizontal line. It's this line. Okay, that's where y is always 3. Maybe you want to just, in your notes, write this down. If it's y equals, that's going to be a horizontal line. Remember horizontal's this way?
I always forget that.
I know. Here's the other little trick that I sometimes tell people to do. If you take a Y and you flip it upside down, doesn't it kind of look like an H for horizontal?
Isn't?
I guess.
Wait, why is Y horizontal? Isn't
I know, because Right, so that's tricky because this is the y-axis, right?
Wait, what?
This is the x-axis. But no, this is perfectly logical. Think through it. Where does y always equal 3? Well, if you're on the y-axis at 3, it's here. 1, 3 is here. 2, 3 is here. 3, 3. It's your y value that's not changing, right? If you move up the y-axis 3, that's y equals 3, okay? Or I always say x equals, that's a vertical line. Here's what I tell people on this one. It's like a V with an upside down V, right? If you put two V's together, vertical, you get x equals, okay? So upside down Y is horizontal. Two V's put together is your x equals. That's the vertical line, okay? Can you give it back? Okay, we'll talk more about those. We'll do more, what line do we reflect over? But let's just reflect this one that we have right now. So this says you have the coordinate 2, 6, and we want to reflect it over this blue line. We said it has to be the perpendicular.
0, 3.
Yes. Oh, no, not 0. Sorry.
Oh.
No.
No, 3, 0.
2, 0.
Oh,
I think you just moved too many. So look here. You go how far you are perpendicular to the line. So perpendicular to this line is right here, right? So 1, 2, 3 units above.
Oh.
We want to reflect over the line. So we want to go 1, 2, 3 units below. And this point then is F prime. Okay, that's your new point.
Wait. What?
Okay, so it has to be perpendicular, which is why if you're horizontal with your line, you have to go vertical, right? Perpendicular to it. And that'll be your new point. Okay, let's take a look at this one. Start by graphing these points. So negative 4, 3. 1, 2, 3, 4, 1, 2, 3. There's your x. 2, 6. 1, 2, 1, 2, 3, 4, 5, 6. That's your y. And negative 1, negative 8. 2, 3, 4, 5, 6, 7.
It doesn't fit on the chart.
Just put it right on that line.
I remember this college assignments that never fit my cards. I don't know, like get so mad at her because like, Miss Rock, stop making assignments that make no sense. It
It's
goes
not-
off
I
the chart
remember
every
that.
single problem.
Just add some
No, I
lines.
know, it's so bad.
Welcome to the world.
Yeah, it was so
like,
bad.
The
It would
graphs
be
are
like,
like half as small as this, and the numbers are like twice as big as this. Like, it's
Well,
every problem.
It might happen for you guys
it
here
would be
too,
like,
just
like
so
the
you know.
graph would go to 9, and then the problem would go to like 28, and I'm like, Miss
I know,
Rock,
but do you know what
how do you
you're,
expect me to do that?
but do you know what you're supposed to do in those
Yeah,
situations?
but it makes me so mad.
Yeah, I just
Count-
pull up old homework and it's like.
Just
it's
count by a
like
different
ugly
number,
graphs.
right? Count by a different number. Count by 5s.
I'm like,
Count by
Miss Rock,
3s.
No, I think that's what I did actually. It's either that or I like draw really
How
ugly.
started this drawing? Why'd you do that?
Okay, so take a look at this. Tell me what this capital R stands for.
Reflection.
Reflection. Okay, so we are doing a reflection over what? Over, so this is what we reflect over. Whatever line is like that little subscript line, okay? So they want us to reflect over the x-axis. Now, where is your x-axis? Is it the yes, it is the horizontal one. This is your x-axis, okay? So if we're gonna reflect,
Can I show you the homework you would give us?
no, because we're gonna get really off course if we do that, and I want to get this done. So if we're gonna reflect over the x-axis, put it away. We're reflecting over the blue. Okay, now hear me, because inevitably, when it becomes a triangle instead of just a point that you're reflecting, it seems really confusing. So I need you to not see this as a triangle. I need you to see this as just 3 separate points that have to get reflected, okay?
Okay.
So forget about the fact that there are lines. Look at point X.
Okay.
if you're here and we're going to reflect over this line, where should you end up?
Three down.
3 down, right? Right now we are 1, 2, 3 above the line. So you need to go 1, 2, 3 below the line and call that what point?
X1.
X prime.
Yeah.
Okay? Go to your Y. Where are you in comparison to your line right now? Are you writing these down?
6.
Right now you are 1, 2, 3, 4, 5, 6 above. So you need to go 1, 2, 3, 4, 5, 6 below. And that's going to be your Y prime. Now this is usually the one that gets done wrong. Look at Z. Where are you right now compared to your line?
I probably did
8
it
down.
You are 8 below the line right now.
Yeah.
Where do you need to go to reflect over that line? You need to go above the line. So 1, 2, 3, 4, 5, 6, 7, 8. You're going to go 1, 2, 3, 4, 5, 6, 7, 8. And that's Z prime. Okay? Now here's the deal. My little squiggles, I don't need to see those from you. If that just creates more chaos for you, I'm just doing it to show you where I'm going, right? You don't have to do it that way. If you like it that way, go for it. But if it just creates a whole lot of chaos for you, then just count. Just do taps, right? But your answer then is this triangle. Z prime to X prime to Y prime. Okay? You just draw in the triangle you were working with. So it's this triangle. You don't have to shade this in. I'm just helping you to see what we're looking at here. If you want to shade it in, go for it. But you don't need to. Okay? So we took that triangle and we flipped it over the x-axis.
Holy guacamole.
Questions on that?
And when we write them into like those equal signs, will we put R and do that?
No, so I don't make you do the equal sign. The book is more about the equal sign. They're just asking you where did that point fall. So X prime is now at 1, 2, 3, 4. So -4, -3 is your X prime.
But I don't have to put the R in front of it.
You don't have to put, you don't have to, like they told you what the rule was. Now you're just saying where did we land. So Y prime is at 2, -6. And Z prime is at -1, +8. But honestly, I could care less if you tell me those points. I'm going to ask you if I can see it on a graph. You're just going to graph it for me. Okay?
Can I show you the homework?
No. Okay, so now here's what I want to know. If you are going to write a reflection rule for me for these pictures, let's start at, it asks you to describe triangle 2. So here's your triangle 2.
What do you like him up?
What would you say triangle 2 reflects over which
4.
line, and what does it become?
Becomes 4.
It becomes 4
And it reflects over K.
after it reflects over line K. Do you see that? If I drew this line in, if I took a piece of paper and I folded it, my 2 would match up perfectly on 4, right? So we could say, for a rule, a reflection over line K of triangle 2 maps onto triangle 4, right? That would be the rule for that. A reflection over line K of triangle 2 maps onto triangle 4. Okay, so you see if you can duplicate that
Is that it?
with triangles 1 and 3. Write a rule.
It seemed like it was worse.
Write a rule for those.
Done.
Finished.
I'm done.
Good. All right, Cadence. Tell me the very first letter you wrote.
I only wrote the rule. I honestly don't know how to do it.
Well, if you're duplicating this,
Uh-huh.
but for this information, What's the capital letter we're using?
Okay.
Bro.
No, what is our is it a translation? Is it a reflection? It's a reflection. So you're gonna write R, right? Okay, then what is gonna go subscript here? What's our what we are reflecting over? Luke. Line what?
Line M.
Line M. Okay, so we're saying right now this is a reflection over line M of, what did you do, Isaiah? Which triangle?
1.
Okay, so if you say it's a reflection over line M of triangle 1, that maps onto what?
Triangle 3.
Triangle 3. Did anyone say that differently? Did anyone say triangle 3 onto triangle 1?
No.
Doesn't
Okay,
matter.
you could, right? If it didn't tell you which one had to be your starting point and which one your ending point, it's the same thing.
9.3. Like,
Okay,
is there no-
we're not doing 9-3, yeah. Okay, last thing I want to do, go back up to just example 1 for a minute, or you don't even have to write this down. I want you to tell me, where is the line x equals -1 gonna be?
The whole
It's vertical, and where do you move?
up and down.
1 to the left, okay? So x equals -1, that would be this line, right? That's x equals -1. So if they tell you to reflect over x equals -1, that's the line you want to draw in, okay? What if they tell you to reflect, let's pick a new color here. What if they say reflect over y equals -3? What kind of line is y equals? It's horizontal, and you're going to go down 3, right? So this is a horizontal line, but from 0, 0, 1, 2, 3 down, a horizontal line. Okay? What if they tell you to reflect over the y-axis? Which one's the y-axis?
Horizontal.
Well, y equals is horizontal.
Oh,
This is the y-axis, right? So that's what I need you to keep straight. The y-axis is the vertical one. That's this one. The x-axis is the horizontal one. But when it's y equals some number, that's a horizontal line. And when it's x equals some number, that's the vertical line. Does that make sense to everyone? Because that's what gets real goofy. Okay.